All right, let's talk about a mental trap, one that probably catches you all the time, especially when you're scrolling through the news. It's this huge idea, correlation versus causation. And trust me, by the end of this, you're going to see it everywhere.
I bet you've heard this one before, right? Correlation does not imply causation. It's like the #1 rule in statistics. But what does that actually mean? I mean, really. Getting this one little phrase is a total game changer for how you see the world and all the data in it.
So, what's the big deal? Why is this the most important rule in data? And more importantly, why is getting it wrong so dangerous? Okay, let's dive in and break it all down.
Okay, first things first, we gotta get our terms straight. You might hear correlation and causation and think they're kind of the same thing. They sound similar, right? But nope, they are worlds apart. This chart really spells it out. Think of correlation as, well, it's like two things are dancing together. They're moving in sync. A moves, B moves. It's a partnership. But causation? Oh, that's a whole different story. That's a one-way street. A pushes B. It's a direct shove, not a dance.
So correlation is basically just a pattern spotter. It looks at the data and goes, look at that. These two things are happening at the same time. It's an observation, a clue, but that's it. It has no idea why it's happening.
Now causation, that is the why. That's the holy grail. It means we've found the trigger, the actual mechanism. One thing literally makes the other thing happen. We're talking pure cause and effect. It's the engine that runs the universe, basically.
You know, our brains are hardwired to find patterns. It's how we survived for thousands of years. But in today's world, which is just overflowing with data, that same instinct can seriously backfire. It can trick us. Let me show you a perfect, classic example of how.
Okay, check this out. It's a famous one. The data is crystal clear. When ice cream sales go up, the number of people who drown also goes up. The two lines on the graph move together almost perfectly. The correlation is, well, it's undeniable.
So, what are we supposed to think? Does eating a scoop of chocolate chip cookie dough somehow cause you to drown? I mean, it sounds completely absurd, right? But if you only look at that data, that's the conclusion you'd have to draw. And this is exactly where we need to stop and think. And here's the twist. The real villain here isn't the ice cream. Of course not. It's summer. Think about it. Hot weather makes people want to buy ice cream, right? And what else does hot weather make people want to do? Go swimming. And more people swimming, sadly, leads to more drowning accidents. The summer heat is the hidden cause that drives both things.
This hidden cause actually has a technical name. It's called a confounding variable. You can just think of it as the villain in our data story. It's this third wheel that jumps in and makes it look like there's a direct link between two things, creating a total illusion. Okay, so if these correlations are everywhere and they're so tricky, how on earth do scientists ever prove that one thing really causes another? How do they get past all these hidden variables? Well, they have a secret weapon. It's called the gold standard for a reason. It's called a randomized controlled trial, or an RCT for short. And honestly, it's brilliant in its simplicity. Here's how it works. You take a bunch of people and randomly, and that's the key word, randomly, split them into two groups. Group A gets the real deal, like a new medicine. Group B, the control group, gets a fake, like a sugar pill. Then you just sit back and compare what happens to both groups.
That random assignment part, that's the magic. Because when you do it randomly with enough people, the two groups become basically identical in every other way you can imagine. Their age, their habits, their background, you name it. They're mirror images of each other. So if you see a difference in the outcome at the end, it can only be because of the one thing you did differently, giving one group the real medicine. It just erases all those pesky confounding variables.
And look, this isn't just some boring textbook stuff. Getting this wrong has huge, real-world consequences. We're talking life and death. Let me walk you through one of the most infamous medical stories that proves just how dangerous this mistake can be.
So back in the 1990s, studies were showing this really strong correlation. Women who took something called hormone replacement therapy, or HRT, had way lower rates of heart disease. It seemed like a miracle drug. Doctors were prescribing it, everyone thought it was protecting women's hearts. But then 2002 happened. A massive RCT, that gold standard test, was published. And the results were a bombshell. The truth was the complete opposite. HRT didn't help, it actually increased the risk of heart disease.
So what on earth was going on? What was the hidden cause this time?
Well, it turned out that the women who were taking HRT back then were already healthier to begin with. They tended to be wealthier, have better diets, and better access to doctors. It wasn't the HRT that was protecting their hearts, it was their overall healthier lifestyle. That was the confounding variable, and that single mistake led millions of women and their doctors down a very dangerous path.
So, let's wrap this up. What are the big takeaways here? Number 1, correlation is a hint. It's a clue. It is not the final answer. Number 2, you've got to be a detective. Always ask yourself, what's the hidden cause? What's the confounding variable here? 3, when you really need to know if A causes B, the randomized controlled trial is your best friend. It's the gold standard. And finally, never forget that HRT story. It's a powerful reminder that this stuff really matters.
So I'm going to leave you with this challenge. The very next time you see a headline in the news that says, "Study shows X is linked to Y," I want you to stop, take a breath, and ask yourself, okay, what's the hidden summer in this story? What else could be going on here? Learning to ask that question, honestly, it's like having a superpower in our modern world. Now go use it.